and welcome to episode 198 of The Joy of Coding. Hello, how's it going? My name is Mike Conley. So glad to have you here. I'm going to be hacking on some Firefox stuff today. That's the situation. We're starting a couple of minutes late, but the good news is that the restreamer is working for YouTube and for Twitch, and everything seems to be like working out right now. So big thumbs up to Andy, who's watching this stream, I believe, is monitoring and making sure everything's running okay. Thank you for all of your support and help. The restreamer appears to be working today. Let's get down to business. What are we doing? Hold on. Yeah, so here's today's agenda. Today is November 20th, 2019. A reminder, no plan survives breakfast. This is something I say every time before the stream, and it's no exception for today as well. I don't really know what I'm going to do today. In fact, I haven't even set up an agenda. So who knows what's going to happen today. I'm just going to sort of look at my work queue and see what there is to do. And we're going to work on it. And things might go wrong. I might get stuck. We might fix a bug. We might run into a bug. Who knows what's going to happen. But, there's really not much of a plan. I'm capturing software development in the raw. So if you're wondering, like, wow, man, this Mike guy really should have had his act together before he ran the stream. That's not the point of the stream. The point is to capture it live as it's occurring in the raw. So that's what's going on there. The second thing I want to point out is that the agenda that we're looking at is something that you have access to. If you're watching this on Air Mozilla, check out the handout section to my right, my left, your right. And if you're watching this on YouTube, then there is a video description down below with the agenda link in it. And if you're watching this on Twitch, then I'm about to drop it in the Twitch chat. Boom, there goes the dynamite. Link is now in the Twitch chat. There you go. And that allows you to click on all these links. And as I update this with the things that I'm hoping to work on today, this little spinny up here in the top right will spin. And then if you refresh the agenda, you'll get the most recent version of the agenda. I want to take this opportunity to plug the episode guide. This is something that's completely viewer driven. So viewers just like you are working on making the episode guide useful and filling it up with information. We've got episodes all the way from episode 1 all the way to episode 195. And today is episode 198, and that means that we've got a couple in the hopper probably. Yeah, and if you take a look, we've got 2 pull requests. I'm going to take this opportunity right now to merge these. Episodes 196 and 197 are in the queue, so let's take care of that right now. Once again, thank you to Smurf D for doing this. I'm going to show you how I review these things. The first thing I do is I look at the date, make sure that that's correct. November the 6th, episode 196, that is correct. That was the date for that episode. And then I make sure that the links work. So let's follow this link, make sure it's for episode 196. Well, while we're waiting for that to sort itself out, we'll make sure that the agenda is also set up correctly. Episode 6, 196, that's right. Huh. What's the dealio here? Is that the right link? Event redirect 348. Let me try it. Let me try this link in a private browsing window, actually. Yeah, this looks right. 196. And the reason maybe it's locking up for me is because I'm currently presenting right now. And so that's why it might be loading up the presenter console. Okay, but for people who aren't logged in or aren't presenting, then that will work. That's great. The topics I covered, we were looking at an intermittent test timeout for picture-in-picture. We filed a bug for review. We talked about the audio toggle, talked about weak references. We were gonna look at this, but we never did. I think this actually we could do today and work on it and like get it up for review. So let me copy that, put that in there. A link to the rating of the episode, might as well check that link as well. 196, that's right. And then all this stuff. That looks great. Good, good, good. Okay, so I'm into that. Thank you so much, Smurf D. I'm going to confirm and thank you. Comment. Next one is pull request for episode 197. It was the week after. That was last week. Let's see here. Oh, this is interesting because it's actually got two episodes in here because it was two commits, one on top of the other. We've just merged the first one, so I'm gonna see here. Yeah, like I think what we want to do is reload this. Smurfy wants to merge two commits. I just want to see the one commit. Yeah, here we go. Just this one. Had 197. That's what I want. Okay. So that was November 13th. That's correct. Episode 197. Yep. And we're going to check this link. Episode 197. That's correct. The Evernote agenda for episode 197 looks right. What do? We talked about stop tracking mouse over videos inside of Will Destroy. We filed that bug. I think we came up with a test case for it too. Charged Neon had this idea for a great background and that landed. Yep, so we gave a thumbs up to Charged Neon. Moz Fab, we talked about that. We didn't get to thumbnail or test issues, but those have actually been fixed. So good news is that that's done, and we didn't get to reading Emilio's blog post about leak hunting, but you should if you're interested in leak hunting. That's a great blog post. And let's just quickly make sure that the form is correct. 197, that's right. And then these are all pretty much the same as before. This looks great. So once again, I'm going to merge this. Thank you so much. And like that, the episode guide is up to date. So if you go to the episode guide now, episode guide, and let's reload. We have 196 now. 197 should be up shortly. Once GitHub does its thing and updates its like internal snapshot of the pages. I'll just give it another. I'm just gonna hammer this reload button. Come on. 196. One more time. 3, 2, 1. Reload. No, it's not there, but it will be shortly. So thumbs up. So what do we want to work on today? Well, one idea was this leftover bug, which was that has been in my queue, and what that will do is actually don't know if we want to run that. If we want to do this or do something slightly different. I'll explain when we get there. So let's keep that in the list. What are other active bugs I've got working on? This one, yeah, this one we can probably land or get reviewed on. Sorry. Let's put that in the agenda. Actually might do that one first because it's just basically putting a patch up for review. What else is in the hopper? That's blocked on review. That's blocked on review. That's blocked until the Will Destroy stuff is landed. That one we also put up there. So what other thing was I thinking? I've got my review queue. I could drain my review queue. That's a good idea. So drain review queue. And the other thing that we might want to work on is to look at some performance profiles for startup. Startup performance profiles. So I'm going to poll the audience. I don't know how many people are watching this on Twitch right now. Let me actually pull up the Twitch page. You know what I really should do is have like an interface for doing polling in the Twitch chat or something. Mute. Oh, fun fact. There was a bug in how Twitch was supporting picture-in-picture where pause and play wouldn't work. That has been fixed. So if you use Twitch and you use picture-in-picture, then the play button works now. The play and pause button. So that was actually Twitch that landed that fix inside their own player code. So pretty happy about that. There are 4 people watching. in the Twitch chat. And who knows how many people are watching the YouTube live stream? Who knows how many people are watching the Airmozilla live stream? But I'm gonna poll the audience. If you're in the live hacking IRC channel or if you are in the Twitch chat, I want to get your sense of what I should work on today. Should I review some patches? Like, what should I do first? Do you want me to review patches? Look at some startup profiles to try and find things that we can improve for startup time? Or should I, work on some of these bugs? Or, what's the preference? What are the preferences? And if there's no preference out there, that's fine. I'll pick something. But let me see. I'm going to give people, well, because there's a little bit of a delay, I'm going to give people 20 seconds to vote. Let me play a drum roll. We got one vote in from Smurf D. Two votes for startup. Three votes for startup. I think at this point, we're gonna look at some startup profiles. So I'm gonna show you how we investigate performance issues. In particular, this is a really excellent time to do this because we recently landed, I didn't land this, but one of our continuous integration fine folks have landed a patch that makes it so that we collect what are called performance profiles. And performance profiles are like a readout of what the browser is doing during a window of time. It collects performance profiles in the startup window. And it does that not on every push to Autoland, but on every merge to Mozilla Central. So that means that we've got information going back now a couple of days. We have easy access to snapshots of what startup is like when running the performance tests. So let's take a look at that right now. Let's see if we can find some of those. I don't actually know if that's been merged to Central yet. Let's see. We're gonna filter jobs. I'm looking for Talos Prof. Nope, not yet. But I know that he pushed some to try. So let's go to try Talos Prof. Let's look for author. Try author equals, instead of mcon, we're gonna say rwood. Yeah, tprof, that's what it's called, tprof. Maybe we actually have some Mozilla Central ones. It's called tprof now, not Talos Prof. Tprof. Not yet. Those are coming soon. I think he just landed the patch to make it happen, and it's possible a merge has not occurred yet. Let me just see if I can find the bug. Talos profile central bug profile central. Where is it? Bug Talos central. Talos test run central with Gecko profiler enabled. It's this one. This went to Autoland 3 hours ago, so it hasn't actually landed to Central yet. But we can look at some of his try pushes, and those were applied on top of Central, so we can work with this. Now we've got profiles on Linux 64 shippable. I'm actually interested in looking at it on Windows to start. So let's take a look at Windows. There's one that he did here on yesterday, Tuesday. We've got profiles for startup will be under the other category, that's O. And we have these like these tests. Window opening, startup with about home. This one I've actually already looked at a little bit, but we can look at it some more today because I didn't really go deep. So let's open up that one and TS Paint. Whoops, hang on, go back. I want to open them in a new tab. Okay, new tab, that's startup, about home, and then TS Paint, that's this one. We also look it up on session restore, restoring a session. So about home, TS Paint, session restore. And we're gonna start looking at these and see if we can make some sense of what we're seeing. And if you've ever watched my other series that I do very irregularly sometimes on Fridays with Jeff, you'll know that analyzing performance profiles can be a little tricky, but we're going to go into it and see what we can get. Lots of different cycles here. So startup about home paint, there were only 2 cycles. There were 20 cycles of TS paint, and there were 10 cycles of session restore. Let's take a look at the first cycle of about home. Let's look at the first cycle of each, actually. And let's take a look. So there's a lot of information here. Lots and lots of information. And there are lots of colors. It's a little overwhelming. But let's see if I can kind of break down what's going on here. So time is progressing from left to right. And these little shapes, these curves of colors, represent different types of activity that are occurring during any particular slice of time. So this is like the 0th moment of startup. And this is at this point where like things kind of cut off. That's when the test ended. So startup was considered complete at that point. Same thing goes for the TS paint test. So this was TS paint doing its thing, and yeah, it completes roughly around the same time. 1.1 second. What's this one? 863 milliseconds. 1 point. I'm curious to know. It's possible that the profiling stops not necessarily whenever the test ends, but whenever like the other things have occurred. We'll investigate later. And this one is the session restore one, and you can see like there's a long period of nothing happening, and that's because we wait a good 10 seconds to determine like whether or not any more tabs have restored, and at that point, if none have, then we use the last tab restore as like our timestamp. So these are our 3 tests. Now the first thing I like to do, I find these colors actually kind of overwhelming. They give like a lot of information about what category of thing is occurring. Like gray means other, yellow here means JavaScript, blue means DOM, dark blue is like more DOM. Oh, light blue is network, dark blue is DOM, purple is layout, orange is like garbage collection, green is graphics. Those are the broad categories. Lots of JavaScript throughout. What I like to look at actually is stack height. So every time each of these little like spikes, I shouldn't say spikes. Each of these little columns, like if I scroll in, they're like, this is a histogram made up of like lots of little columns. And each of these columns is a sample. So the Gecko profiler is a sampling profiler, and what it does is it stops the entire process, all of the processes in this case, every 1 millisecond, and it asks it to do a readout of what it's doing. So every 1 millisecond, dump a stack, and then keep going. So it happens pretty frequently, and that's how sampling works. It's like pause, take a snapshot, and keep going. So that's what each of these represents. And the height of the column represents how deep was the stack at the time of the snapshot. And that's useful for knowing whenever there's actually activity occurring. Like if you take a look at this, all of these samples are taken at the same stack height, meaning that probably not a lot's there's not a lot of movement. Maybe we're stuck, maybe we're hitting a hang, or maybe we're just polling. And in this case, we are polling. We're waiting for a message. So we happen to be pretty deep in the stack height here, but this isn't a problem. We're just waiting for messages. We're idle, effectively. When looking at the profiler, a lot of these symbols up here are actually what is most useful for like concentrating your eyes on. And in particular, the red ones are where the profiler has detected that we stopped servicing the event loop for greater than 16 milliseconds, which means that if the user had sent some kind of input event, then if they had sent it right around here, it would take them almost 70 milliseconds for that event to have been processed, which is what we call jank. it's possible to have dropped frames during that time. We're blocking painting, we're blocking all sorts of stuff that occurs on the main thread, layout updates, that sort of thing. And so this could be considered a dropped frame. Same with here. So the red lines are like a great way of drawing your eyes to various things. We have all these different tracks, and each of these tracks represent either different threads or different processes. This is the parent process right here. That's the main UI process, and it has some different tracks. This isn't a thread per se, but a readout of various network activities that occur during startup. This is a readout of how much memory consumption changes during startup. You can tell that as we start up, we start ramping up how much memory we're consuming, and that makes a lot of sense. We are, setting up, we're constructing things that we need, and this is a thread. This is thread activity. The compositor thread just kind of hangs out. On the GPU process side of things, I think the compositor thread is mainly used as a backup in case the GPU process ends up not working, because we're actually doing compositing here. The GPU process is here, and then we have this compositor thread inside of it doing a lot of the actual compositing work. The GPU process, the main thread in the GPU process, doesn't do a whole lot once it's launched, and I'm not entirely certain why we launch a separate thread to do the compositing. But yeah, there is a... Andrew's like, damn, there's a lot going on, and I'm like, yep.
Hey, what happened?
What happened? So the GPU process is launched. The web extension process launches over here. And that's the main thread of the web extension process. It immediately starts consuming something like 16 megs of memory not long after startup. And then this is a content process, presumably the one that's, I actually don't know. Oh, the one that's loading about home. That's the default home page whenever you start. And that starts around here. There's a big period of jank right there, and then it does some stuff. And then the test ends around here. Let's see if we can sort of get a sense of how the test works in the timeline. We have these different utilities. Like the call tree tells you what was happening, what was the stack like during a particular sample or set of samples. If there's a commonality, let me zoom out. If there was a commonality, let me show you an example of that. So notice all of these samples are highlighted at the same time. That's because they all share the same call stack. So we were doing the same thing throughout. In this case, what we were doing is waiting for a message. I don't know if that means that we're just polling the message loop, and that's a good thing. That means we are idle. We're responsive to user events. So that's a good thing. All of this activity is not necessarily a bad thing. You want to do stuff. You want to get the browser up and running as soon as possible. And if that means doing a bunch of stuff, then do a bunch of stuff. But you want to do the least amount of stuff possible, and you want to do it in the most efficient way possible. And I think that's where we still have a lot of work to do. Where a lot of things, like you're saying, Andrew, 016, there's a lot going on. And that's true. And some of these things just have to occur. We have to construct and paint a window for the user to see a user interface. Full stop. Have to do it. But there might be some other stuff in here that we don't need to do. And that's part of, I think, the performance work, is finding the things in here that maybe we don't need to do all the time or don't need to do at all. And when can we delay them to? Or are there things that we can move off of the main thread? Can we change the scheduling around so that we optimize for perceived performance, like optimize for painting, optimize for presenting the user interface as soon as possible? So let's take a look at the timeline a little bit here. We have this thing called the marker chart, which is that's a graphics bug. That's a little bit of a graphics bug right there. I don't know if you're seeing that, all that black. Yep. That is a graphics bug that I have seen periodically, and I'm not entirely sure. I think it has to do with the tooltips, which is going to be unfortunate. I think it's an invalidation bug with our tooltips. I don't actually know if it is a this might be a profiler bug or a graphics bug in Firefox. I'm not sure, but I should get that filed. In the meantime, I want to look at this because I want to show you where the test starts and ends. So the test starts, this is the about home. The first test we're looking at is the about home test, and the way it works is we launch the browser and we wait for about home, which is this thing, to finish loading and presenting. And that actually occurs in this content process over here, web content. And there's a contentful paint that occurs, come on, right here. The first non-blink paint happens here, and then we composite it here. Where do we composite it? There's some file I/O that happens. For graphics. And then where do we composite? There's like this special event called, not set timeout, it's top sites first painted. That's the one that we wait for. And as soon as we have that, we send the timestamp of that event to the parent process, stop the test, and then we're done. So this is actually the end point right here. So I'm gonna slice all of this off because this is just idle time, more or less, waiting for the front end to realize that the stopwatch has ended. So this is the interesting part of the test. And there's plenty going on. Where do we get started? Well, I'm gonna start by getting rid of some things that I don't think I need to see. I don't need to see this compositor thread, I don't think, because it's not doing much. I think, oh, I see what it's doing. Its job is to notice vsync and tell the compositor process about vsync. And I think that's because we want the compositor process to be of lower privilege, and it's not allowed to know about vsync. So we have to like send IPC messages to tell it about vsync. So that's what this thread does. We should probably call that the vsync thread. But that I don't think is doing a whole lot that I need to care about. So I'm going to hide that for now. I also don't care about memory right now, so I'm going to hide memory. Network I might care about, so let's keep that around. Let's get rid of this memory right here. Compositor might be useful to stick around. Web extensions is useful, but its memory I'm less interested in for now, and same with web content memory. So now we've got a sort of a distillation of the threads that I kind of care about. And I'm just going to pick something at random. Let's see if we can kind of understand the network activity that occurs. So it looks like one of the first things that happens during the startup window is that we look for block lists for for hijacks, people who are like we put up special block lists to help you avoid going to like hijacked domains, and we request those via the remote settings API, and that occurs right here. And we look for changes for FX monitor breaches right here. That's the network request. This one looks for information on what's new about the browser in case we want to tell you about new features. This one, ping center, I'm not sure what that one's for, but I have a feeling that's for about home telemetry. And then this one is for updating the safe browsing database, which is different from the hijack block lists. So all those happen around the same time. That's a lot of network requests that happen around the same time. It'd be nice if we could consolidate some of these. Let's write down some findings, actually. Let's start a new document. Actually, not in active bugs. Let's put it in live coding. Oh, no, not live coding. Maybe... where's a good active code reviews? How about MISC Mozilla? Put it under miscellaneous Mozilla right now. So performance review. Performance profile reviews during live hacking. Now that I think about it, I think this makes more sense to go into live coding for now. All right, so let's start with a link. So this is about home startup, about home paint. Right. Test. There's the link. So let me share this inside of the agenda in case anyone wants to follow along. So let's see here. Notes. So if you refresh the agenda, then you'll have a link to my notes. So the first thing is that we seem to send individual network requests for various remote settings things. What's new? What were the two? Yeah, monitor updates, what's new, updates. Can we combine those into a single request? That's one thing we could do. What is all this over here? Oh, this is not hitting the network. This is like us loading the browser UI document. So that's whenever we start navigating to the browser UI document. We actually do it twice. That's interesting. Then there's a DOM content loaded, another navigation start. Why 3 navigation starts? Another navigation start, another DOM content loaded, and then a load event for a browser, XHTML, navigation start. What are all these navigation starts? And then more DOM content loaded. The hidden window. The hidden window gets constructed. I think I know about this bug where we construct what's called the hidden window during startup. So these I've sort of filtered down the samples until I can show you like the hidden window samples, and there are only 3. They don't account for very much time, but it is more time than we probably need to spend doing what's effectively useless work. This is a known bug. Hidden window. Let me link to the bug. Hidden window. Bug. Hidden window. Hidden window. Don't create the hidden window in a normal browsing session. Yeah. So Felipe did a comparison back in the day and reported session restore and startup about home paint go down by some 0.5 to 2%. Although another one went up. Startup about home paint on Windows 10 64 quantum render went up a little bit right here. But this looks like erroneous. That's a non-related test. Or is it? TP50X. I don't know what those tests are, but T-resize. I don't actually see any like hugely important improvements. Like these go down a little bit. They all go down a little bit. Maybe every little bit counts, you know. So maybe that would have helped. Confidence is low though. Are we within the noise? Standard deviation is 13.62. Standard deviation 3.69. So this one's noisier. But so there are cases where we go like there's a broader spread. I don't know if you can tell looking at these dots. There's a broader spread in the scores. These ones are a little more clustered between 643 and 655. This one's spread out a bit more. It's almost bimodal. But there are a bunch of scores that are down in the 620s, which is really good, actually. So we may have saved some time there. And this one, this is the one where things apparently got worse. But I think that might only be because standard deviation is about the same, 652, 21.7, 23.14, 7. What is it using? The median? Is that what this is? The median? And this one's a bit higher in the 700s. Yeah, that's weird. It gets a little bit worse. So timing changed such that this one scored a little bit worse back 8 months ago anyways. So that's interesting. So let's link to this bug. The hidden window, known bug. What else we have? Well, there were other like navigations here. There's like a navigation start here and a navigation start there. What are those? Can we get more information? Marker chart, navigation start. Can I take a look at the copy marker JSON? Is there information about why? No. That's too bad. What could we be navigating to? Let's take a look at the samples near here. Here we're creating the top level window, or a top level window. Getting presentation stuff. Oh, I know what those navigations probably are. So we have different things, like we might have to navigate to the browser UI code, but we also have navigations that need to occur for other resources like the CSS files, and I think those are considered navigations in this speaking. Or getting the JavaScript, navigating to like, yeah, loading some JavaScript right here. Or opening the browser window. As soon as we observe that the browser window is opened, we do some regular expression stuff. We run this process content script. Little fragment there, not super important. Okay, good to know. So that's where those two navigations, and I would imagine some of these other navigations are for, like all these navigation starts I would imagine are resource loads. There are certain resources like SVGs that are considered things that one navigates to. And I would imagine that's what these are. Initial or documents inserted. Fire all of these things for each SVG. So a lot of activity occurs whenever we're loading all these SVGs. I wonder if we could, can we avoid firing all of those notifications and events for SVG loads? That might be good. We load a bunch of stuff, download stuff. Why would we be loading the download stuff? Downloads common occurs because of the indicator that is loaded because of on load. We run this download stuff. Let's take a look at the source code. On load. So here's a whole bunch of stuff that message listeners. These must run before loading the frame script to ensure that we don't miss any messages sent between when the frame script is loaded and when the message listener is registered. I wonder if we convert some of these to using the new JS window actor stuff, whether or not we can move these over so that they're more lazily loaded. So where do we do the downloads? Downloads button. We do this in onload because we want to ensure the button state doesn't flicker as the window is being shown. So that's why we do it. To avoid flicker. All of these inits, maybe they don't need to happen right away. Let's look at like captive portal, for example. What's the captive portal watcher? Captive portal watcher init. Captive portal watcher. Send browser captive portal. What does init do? It adds a bunch of observers. It gets this service. Here, let me pump up the font. If we think a captive portal's already been detected, otherwise we recheck every 500 milliseconds. Then delayed startup, we recheck. Right? So where do we, what messages are you talking about? I wonder if we can message, I don't actually think, what's it called again? The captive portal watcher. Why would we need to run it so soon? Captive portal init. We add observers for these things. What do we do when we observe them? I don't think any of these things necessarily mean that we have to do them before load or on load. I think we can probably move captive portal. Move captive portal init outside of on load into either delayed startup or idle startup. So that's one thing we could do there. Get rid of a little bit of captive portal stuff. If we like back out a little bit, let's see how much time captive portal. Whoops. Portal. Why? Barely any samples. Browser. What was the file called? Browser captive. Yeah, there's like barely any samples for it. So what? I don't know if that would actually bias anything. Captive. Yeah, we load the subscript for captive portal right here, but that does not take long. 0.071. So in terms of priority, I don't know if that would actually help us much. Where's the? I don't even think I see us doing the captive portal collection or captive portal pinging, but that might be because we're running in Talos. Let's take a look at how the Talos setup works. Because we might actually disable captive portal scanning in Talos, which makes a lot of sense. We don't want to be doing network in the Talos tests. Talos captive. Nope. Testing profiles perf. Captive. Nope. Test Raptor profiles. Testing. Maybe we just disable it by captive portal detection. Network, captive portal service. Is there any part of us that... So by default it is on. And it doesn't look like we do much. Unless maybe we have something in here about automation. Captive portal. Portal service. Captive portal service. Captive portal. It's a service. portal service. Automation? No. Very interesting. Portal. Where's check captive portal? Oh, here we go. If local connections are disabled, which is true, non-local connections are disabled in Talos, then we will error out here when attempting to start the captive portal service. Okay, that's interesting. So if we error out, CPS start. Who calls start? Who calls start? Here. Inside of preferences being changed. And also when we set the connectivity, start. So this will actually, the return value of start is being ignored. That's probably okay. So we don't do anything. We don't actually perform the check. Very interesting. Okay. Well, let's see. That was interesting. Let's keep going. But that might explain why we don't see any captive portal activity in here, and that's kind of a problem actually. The captive portal code is something that runs during startup, but we disable it for our performance tests because we don't want our performance tests to actually hit the network. I wonder if we should like alter the captive portal code. Alter the captive portal code so that it can run during Talos, but communicate with a local server. Because I'm pretty sure the server that it uses, there's something called like success.txt. Detect portal. Yeah, the connectivity service URL. We can change that to something local. And have it run. Okay. So that I think is worth doing. To do, file a bug for this. So that doesn't actually improve performance, but it gives us a better, like richer profiles because they're more accurate profiles. And they could highlight things, excuse me, that we could do to improve startup. Excuse me. Because the more accurate, the more realistic these tests are, the easier it is to find things to do. Smurfy asks, hey, but wouldn't the download button always be great when you start up the browser? Not necessarily. That we actually don't show the download button by default. We hide it by default, and then you can like make it so that what is it? Yeah, auto hide in toolbar is true. So by default, the download button does not exist. And yeah, thank you for saying bless you. Bless ya, says Smurfy. Let's keep going. I think we're on a roll here. I hope this is interesting. If this isn't interesting, if you're bored, let me know. But I find this interesting. This is like the guts of performance work. It's almost like fishing for... It's like fishing or like looking... You've got a big net and you're in a stream that's been well fished, but you're looking for more fish. and you're looking for big fish. And I have a feeling most of the big fish are gone, but who knows? Maybe I'm wrong. Let's see what else is in here. We load all of these things that I'm not sure if we need. Notification box, radio. There are a bunch of bindings, yes, that we need right off the bat. But there's like a bunch of stuff that's loaded I'm not sure that we need. Cookie database read, browser, DLL loaded main thread. What DLL? DLL loaded main thread. GMP stuff. What DLL would we have loaded? Copy marker cause. Let's take a look at the marker cause. Notified DLL load. What DLL was it? It doesn't actually tell us. It's not super useful unless there's other information packed in here. Copy marker JSON. Maybe it's in the JSON. No, it doesn't tell us. So that'd be great if it could tell us the DLL. Now, I wonder if we don't do that by default because of privacy reasons, to tell what DLLs there are, because we don't know. We don't necessarily want to know what other software might be running on a person's machine. Now, in this case, this is a machine that we control, but we're always really cautious about accidentally loading stuff that we don't want whenever you like collect a profile, because like a profile is very sensitive. You're collecting your browsing activity at a very, very deep level, and we want to make it possible for you to send us these things, but to like only include the necessary stuff so that we don't see things that we don't want. Like, for example, resource URLs, what pages you're on, what extensions you're using, screenshots of what your browser looks like at a particular time. Okay, let's see here. Ready state change. We loaded some DLLs, and then we loaded like this GMP thing, GMP change. So we were probably scanning the disk for Gecko Media plugins. That's what GMP stands for. And that might be why we loaded a DLL on the main thread. Chrome page hidden. What page? We unloaded a browser. What the? Visibility change, unload. Where are we here? We're at 161.164. Let's zoom out a little bit. Now let's zoom back in. 0.164. No. 0.164. We need to somewhere over here. We unloaded browser XHTML. We loaded and unloaded. What? Why would we have done that? The actual, so I'd love it if I could like add a, you know what I should do? File or feature request to do file a bug for making captive portal run during Telos. File a feature request for profile to add custom markers, like playhead markers to like remember my spot, markers, bookmarks, kind of like what you might get in video editing software. Because I'd love to be able to like remember where a thing was. Because if we zoom out, the actual load of browser.html, I think it's supposed to happen over here. That's when we reflow it. Where does the load event occur? Starting with layout, finish the layout. DOM browser.xhtml. No. Where is it? That's when we paint it. What is this one? Do load subscript. We load browser.js. And we load more script. We're not loading browser XHTML here. We're running a script inside of it. Tab browser. Let's look for tab browser.js. So here, for example, we are constructing tab browser dash tabs. We init it, and that happens because we do on DOM content loaded of a browser window here. DOM content loaded. Yeah, that's what I wanted to show. Now unload. There was an unload that happens. We saw it. Oh man, where is it? Marker chart, unload. Unload happens way back here. And unload, and what about DOM content loaded? So we have an unload back here, and then a DOM content loaded here, browser XHTML. More DOM content load, and that's probably, and then DOM content load for the hidden window stuff. And then an unload of an about blank here, and more unloading of about blank. Why would we be unloading browser XHTML unless this is the initial? Let's zoom in a bit. I just want to unload. Home page hidden. Ready state change. Stop request. This might actually just be a red herring. Like one of the initial. This is before unload of XHTML. I got a feeling this is a red herring. A red herring, just so you know. Load, DOM content loaded. Load. First unload. I think Chrome manifest loaded, DLL loaded, non-main thread. So I think this first unload is actually occurring not because we had loaded a browser XHTML and then are unloading it uselessly. I think it's because as you transition to the page to load the UI, we check to see if like the current doc shell, the thing that loads the document, has anything in it, and if so, we unload it. But there's nothing there. But we still go through all the code to like unload some things. I got a feeling that's reasonably cheap, but I should double check. We seem to unload browser XHTML before loading the actual one for the browser UI. Is that necessary? Can it be avoided? And how much of that? How much would that buy? So let me show an example. I'll load, DOM content loaded, unload, and then DOM content loaded. So we'll zoom in there, and we'll permalink. All right. zoom out a little bit. What else do we have? If we load all this stuff like C types and the GMP provider, who loads C types? Why would we want C types? C types, C types, who loaded C types? Oh, file IO. But this is off main thread file IO, but we still need to load C types to do it? What? GMP provider causes us to load file IO thing. When it starts up. The add-on manager is starting up and it's like, hey, do we have any GMPs around? Can we do GMP startup after GMP provider startup after onload or after or in the idle callback, or maybe before the first user network request? Stuff. Profile do change fires, and we do some stuff there. Here we're initializing a database. That's interesting. Let's take a look at like SQLite stuff. Let's see if we can zoom out and see how much SQLite stuff we're doing on the main thread. A little bit, at least in these samples. Here it's opening the permissions database pretty early on. Here it is the storage database, cookie service. Right, sorry, the cookie database right here is loaded on the, we execute some stuff on the main thread. Which is interesting because the cookie database I think is supposed to be async now, cookie service. At least it's supposed to be. Cookie service. Cookie service. Get cookie string. Oh, this is synchronous. Cookie string, set cookie string. Underline. Do this many times, runs faster, suggest route, single transaction. Cookie service, cookie permissions, cookie manager. What's that? Remove all. Add something of a backdoor. Cookie. We're looking for async. Cookie service child p cookie service. Looks like the cookies API is mainly sync still, but in the child, cookie service child, move cookies, notify, track cookie load. So this is a big project, but like make cookies all off main thread. Move cookies DB off of the main thread of the parent process. That would be a good idea. There might be a pre-existing bug. Cookie main, that's what I'll look for. Cookie service causes main thread I/O. Blocks for 300 milliseconds for new profiles. Avoid main thread I/O for cookies. Cookies databases run the main thread for first paint. Let cookie database start read off main thread. We have two database connections. syscon is for startup read in the cookie thread, and dbcon is for later usage in the main thread. Unfortunately, they should be initialized in the corresponding thread. If we want off main thread the initialized in dbcon, we need off main thread all the operations. It would be better if we make off main thread all the DB access. I did the startup read off main thread only since the most severe jank happened on the startup thread. The same thing as well. Here's my current understanding of what happens. Early during startup, cookies database is opened off the main thread, and expensive operations like creating tables are performed off main thread. Then a message is posted to the main thread, which triggers init dbcon to open the cookies database on the main thread. Opening the database from the main thread, there it is main thread IO, which blocks the main thread. This is what I caught in the profile. When you first HTTP needs cookies, ensure read complete calls init dbcon. If it hasn't been called yet, the telemetry probes record how frequently this unfortunate case is encountered, and it's rare. Those places be advised what to use. Improve the main thread IO here. Having our own comments. This is changing call site. I can't comment regarding specifics of the cookies code that I only partially know. There may be reasons why async to initialize the database is not possible. For example, we receive a cookie request and we're not done yet. If it is possible, using an open async database is okay. Doesn't seem super easy to do because there are a couple dependent calls that also need updating. If the async opening does anything for file caching, P3 for now. This is a large project, so known issue. What else do we have? So I hope it's obvious that or what you're seeing sort of helps demonstrate. It's not like one thing that prevents startup from being fast. It's like many things have to occur. Lots of OS file being loaded. Crash monitor, GMP monitor, extensions, profile, age, search service, page thumbs, places, pref service, places backups, extension settings, session worker, add-on stuff, activity stream. Activity stream does a bunch of, let's look at activity stream. Activity-stream. So that's interesting. There's a bunch of code over here in activity stream land. We initialize the store. That's in success, having gotten something out of IndexedDB. So we get something out of IndexedDB, and then we initialize the feed. Initialize the feed. It only takes 2 samples, but like this adds up. What does it mean to initialize the feed? Lots of JavaScript. They're using IndexedDB for storage. That's good. Router. So I'd love it if we could like delay all of this stuff until after we've painted a cached version of About Home. Serve browser ready. When does on browser ready fire? Whenever we've restored the windows. When's that? Here. What's all this? This is loading up. This is parsing all of the activity stream code. Parse, parse, parse. We take like, wow, 70 milliseconds to parse all of it. The bundle. It's a long time. Delazify lazily interpreted function. It's like a bunch of compressed stuff. Wait, are we parsing? Yeah, we're parsing it every time. I think part of the advantage of there was this thing called the re-enable was it privileged content process, because what we were able to do is like only parse it once whenever it's first loaded and then throw everything that we've parsed into the startup cache so that we could avoid reparsing it every time. That's waiting on some fission-y stuff though. It doesn't mean that we get to skip executing it, but we could at least avoid the parsing stuff. Getting style. React DOM. Using React, React. Redux. Lots of Redux stuff over here. A little bit of React stuff. Let's go. What is this? Redux. Rehydrating. We handle a message. Handle a change. We notify subscribers. React happens. Then we render. And dispatch to stuff being sent to the middleware. Did update. Presumably it's this last paint down here that we care about. Oh no, where's the paint that we care about? Marker chart. Where is that user timing event? This one. User timing event. Yeah, this paint right here I think is the one that we care about. So let's maybe focus a little bit of time looking at the content process now. From here to here, that graphics bug blows. That's a terrible graphics bug. I will be filing that. Whoops, file graphics bug. In profiler, triggered by tooltips in marker chart. Let's see if I invert the call stack, things steps out. So there's a long period of time where we don't do anything. That's interesting. It'd be nice if we could compress that time. What are we waiting for? A message, where we're waiting for a message from the parent. My guess is we're waiting for all of that activity stream stuff to fire before we do any of this. It'd be lovely if it kind of had everything it needed at this point. We move all this back, we'd slurp back this time. And what's all this is just the loading of activity stream script. What's this? Running the script. And before that, what are we doing? Loading. Actually asking for the scripts. Parsing a jar channel. Handling an event. What's the event that we're handling? DOM link added. Update shared data. Some shared data comes in. Script preloader. More script being loaded. Chrome utils, message manager, remote page manager, child. It's notifying observer on DOM window open. Viewer receiving the list of plugins. What I want to do is become category. All this stuff. Child. Task. GC. Importing a bunch of stuff. Bunch of scripts. File IO. What file IO? Opening the Omni jar. Creating an opening symlink. Sort defaults. What's that? Sort defaults. Copy marker cause. Get environment. We're getting environment variables. For some reason that involves us getting sort default.nls. Getting environment variables. Get default sort file mapping anytime we get the environment variables. Alright. We do that on the main thread. What's this? Local getting a file. The directory service. What directory? Fonts. Loading a DLL. AMD DLL. Initializing graphics. Why do we need to initialize graphics down here? Initializing the child. We get graphics info. Why do we need to initialize graphics down here? Copy. Receive attributes, get service, gang some service, the graphics service. We initialize the graphics service inside of graphics platform init child. What's that all about? Make the provide initial content device data available to the init routines so they don't have to do a sync request from the parent. Then we do init. So it has to be on the main thread. Okay. And then getting the graphics information happens somewhere in here. Here, getting graphics info. Service, graphics info service, graphics info service. And on Windows, graphics info has all of this stuff. Why do we need this? Why do we need this stuff? Does it make sense that the content process is going to initialize graphics code? If, for example, we have web render enabled, aren't we shipping display lists over without touching, without doing things like drawing textures, drawing to textures? So there might be some savings there. graphics code. How much time does it take? Oh, hang on. Call tree. GFX. Bit of time. Bit of time to initialize the fonts. To get the font list. What's here? Loading a DLL. This is all, I think, part of initializing graphics itself. Takes something like 24 milliseconds. Over here. That's not related necessarily. Neither is that. But initializing graphics is taking a little bit of time here. That's interesting. And you know what? It reminds me of something else. This bug. Huh. Yep, old Cleopatra. That's busted. There was a bug that, who was working on it? Andrew Swan. Let me see if I can find a profile. 1 second. One moment. Yeah, this one right here. Excuse me. D3D synchronize. Right here. There's like this big chunk of time waiting. What we were doing was blocked on the paint thread. So this has less to do with graphics and knit, I think. Like, we spent a bit of time over here in knitting graphics. Graphics and knit. Graphics and knit. What was it called? Graphics platform. Graphics platform knit. So still a little bit of time over here. Not much. You know, a modest amount, 40 milliseconds in total inside of some graphics platform and knit stuff. But what he was really worried about was, and I think this is very interesting, is that like the paint thread was blocked right here, the paint task. I'd like to look at that, see if I can capture that again. This was on the reference hardware on July 24th. Yeah, I'd like to see if I can reproduce this and use something like the Windows Performance Analyzer, because like this one is blocked on the graphics driver itself, and so we don't have a whole lot of visibility into why the graphics driver is waiting so long. But maybe we could use Windows Performance Analyzer to try and figure that out. SmurfD's like, but isn't the green ATIX D64 DLL or something a graphics card? Yeah. This is, I don't know when you said that, 1433. It was about a minute ago. Yeah, this is graphics. This is us talking to the graphics card. You're right. And for some reason, it's taking a long time. It's like 3.7 seconds right there for us to like get a response back. And until then, the paint thread is completely blocked. And we're blocked painting, flushing async paints. And we don't know why. So, hang on a second. Let me put a link to that bug that A-Swan filed for that. This is like a startup bug. Blocks, bug start, Firefox startup improvement work for Q2. Startup. Where would this stuff be? I don't know where I'd put this, but I'm gonna I'd like to at least get this investigated enough so that we can have a sense of what, so that we can know what's happening here. I'm going to try to use UI for ETW WPA to try to sort this out. I'm going to take it myself. Reminded me of that thing. I think we should look at it. Long paint, long paint. If we can understand that, that would be a good. That would be good. I would feel good about that. And getting rid of this big gap so that we like process all of this activity stream stuff further. There's this document that Doug Thayer wrote, like a design document. Device Railway 845 says, "Wow, Firefox is still a thing." Yes, it is. It very much is. Hundreds of millions of users. There is such a thing. Yep. Get on the Firefox train. Let's see here. Yeah, there's a design document to like compress all of this time so that we, you know, the privileged content process is able to access the about home data, the about welcome data more quickly and render it without having to wait for this gap, without having to do bounce messages back and forth from the content to the parent. Like give the privileged content process direct access to the information it needs in order to like render itself immediately. So we don't, because the parent, the reason there's this big gap here is that the parent is bogged down doing all this stuff, and eventually it has enough free time to send the message with the information to the content. And in that time, the content process is just idle. It's just hanging out. So that, I think, would be worth doing. I think I'm going to stop here. We're 7 minutes past the hour. Did a little bit of analysis. I've got some things to analyze, or not analyze. Got some things to file, I think. Some stuff in here. And I assigned that bug to myself. So hopefully that was somewhat interesting. That's a big chunk of what we do as part of like the performance team, is to, whenever we're like, if it's not something specific, like why does this drop frames, or why is this so slow? Like why is this one feature so slow, for example? We like, that's a very specific question, or it's a more targeted question so that we can use the profiler to really zoom in. Whenever it's like improve startup speed, especially for something that's so complicated. Startup is very complicated. There's a bunch of like stuff that has to spawn up. You know, it's kind of like fishing. You have to look at the big picture and you're looking for things that don't make sense. You're looking for Waldo. Where is Waldo? Where's Wally? That sort of thing. To find those optimizations to make scheduling work out efficiently for most users. Device Railway goes, performance. Do I work on DevTools? No. I work on performance, and I work on multi-process stuff, and I've been working on the picture-in-picture feature recently. Maybe you, if you're not currently a Firefox user, check this out. Maybe this will compel you to use Firefox nightly or beta and soon release. In a couple of weeks, this is going out to release. On Windows, at least, for Windows users. See this little notch here? I'm going to move my head. You see this little notch? If I click on that, I can bring out the video, and it's an always on top window, so I can like have that playing at all times. So now I've got this. I've opened a black hole. I've got myself in the corner. This is amazing. I'm going to say hi to myself in the past. I'm going to say like, hello self. In the past, and let me just like bump up the font here. We're gonna watch this together. Hello self. And then up there, hello self. And then in its corner, wait until it's gonna get hello self. I don't know if you saw that. Little bit of an echo machine there. All right, let's close that out. Don't need this. That's it. Thank you so much for watching episode 198 of The Joy of Coding. Where were we here? Episode 198 of The Joy of Coding. Thanks for watching. I just wanted to let you know I really value the people who hang out and watch. Please tell your friends. Use Firefox. Be friendly to the web. Use Firefox. Every user of Firefox is a vote for the web and a vote for engine diversity, because we need more of that on the web. If you haven't used Firefox in a while, you should give it a shot. We've been working really hard to make it fast, performant, speedy, stable. You should check it out. And our dev tools have gotten way better. So check it out. And with that, I think I'm going to end it. Yeah, thanks again. And I will hopefully see you next week with episode 199. And then episode 200, where at episode 200, I'm going to do like a spicy episode where I eat spicy food while I'm doing it and probably suffer a great deal. But I'll do it for the people. So with that, take care. Bye-bye. See ya.